Alright, and Falstad circuits, do they work? I took a basic Falstad circuit, which, like I said, I'll just show you on the Falstad. Um, and basically, the one you find online is named this. It's in the transistors called full wave rectifiers. So, if you go down to transistors, you see it right down there towards the bottom just before the early effect. This is what this circuit's supposed to do, and this is how it's designed. The only difference I made is instead of 1K resistors, I used 10K resistors because I noticed the current was going to maybe overload analog discovery if I did this thing for real, so I decided to, make some modifications. Okay, and that's what it's supposed to look like you see here. In reality, this is what it looks like. The yellow, the blue waveform is the input, and the yellow is the output, and they're, both the channel voltages per division are the same. So, you're seeing the input amplitude versus the output amplitude. But, this doesn't make a really terribly great full wave rectifier like it's supposed to be. And I'll, cut the voltage levels down. You can see, how it behaves. So eventually it just becomes a wave. These are both on the same baseline, so the blue wave is the AC input and the yellow wave is a DC output, but right now it's a signal, an analog signal. But once we start getting above about one diode voltage drop, and this is a 2N2222 transistor I'm using too, by the way. But yeah, once you start hitting that voltage drop, then it starts to act like a rectifier. So I don't really see the advantage to doing it this way at all, except that maybe if you wanted a high frequency rectifier, I would imagine this could probably go up there quite a ways. Let's see how far it does go. Let's see. Get down to 2 nanoseconds. That might be too far. Come on. Oh. Okay. Get up there at 3 megahertz, 6 megahertz. Nah, it's not behaving all that well, and as a rectifier at this level. So, I can't really say that the circuit's very plausible, and certainly not as a usable circuit for the looks of things here. Get the frequency down here a little ways. Oops, I'm going the wrong way. Okay, but down here at 300 hertz, that's about the best you're going to get. So I really don't see any practical value to this circuit. Now, why you're seeing a discrepancy is interesting. Because this is what the Falstad circuit looks like with zero load. But watch what happens when I put a load in series with it. Okay, so you're starting to see, we're pretty much getting the same waveform at this point, that you see over here on the screen. So that's where that comes from. So, I mean, Falstad circuits, do they work? Yeah, not really. Not this one, anyway. A lot of them remains to be seen. I've got a few on my list to try. But yeah, this one, I'd have to give a big, hey, interesting result, but not really useful. There's too much of a discrepancy, and the fact this thing, like I said, it's just there's no real advantage to it at all over a regular diode rectifier, let alone full wave rectifier, as far as I can tell. Not that I can see, sure as hell can't handle that much power. You put some shocky diodes or something like that in a bridge rectifier, and make yourself a high speed one that way. Because yeah, this can't even handle high speed. Let's see. I didn't give it enough I'll turn the voltage up on it and turn the frequency up to well beyond what you'd want to use a rectifier at. You know, a few hundred kilohertz. Now let me adjust the scope down to where we can see it. Alright, yeah, no. Yeah, no, that ain't the greatest waveform. So, yeah, I really wouldn't want to use this thing for anything. And given the fact that it's got, like, no components, I mean, you know, there's no capacitors or anything on it, you know, I mean, you know, that's pretty bad. So, yeah, this is like a totally useless circuit, in my opinion. Anyway, cheers.